Hi, this is Ms. Fitzmaurice, and this is an explanation of the multiple choice portion of your practice test. Okay, in our first problem, we want to know what are the dimensions of A in this equation. Okay, so dimensions are kind of like units, except if our unit was meters, the dimensions, and I'm just going to write DIN, would be length. Okay, so the units for length could be inches or yards or furlongs or really anything, but the dimensions are always going to be length. Okay, so in this equation, since we have x, each term should have the dimensions of length. Okay, and what that means is that at squared, or at cubed, has the dimensions of length. T has the dimensions of time, so we have a times time cubed is equal to length. We can solve for a, and we end up with a is equal to L divided by t cubed. Okay, in number 2, it says the displacement of x of an object along the x-axis is shown to the left, and we want to know about its velocity. Okay, we know velocity is the same as slope, and we know the velocity is not zero, except for maybe at this point right here where the slope is 0. We know that it's not constant because the slope or the steepness is changing. For a while it is increasing, and then, for a while it is decreasing, and then it seems to increase, but it's increasing in the negative direction. So the slope is actually always decreasing, and that was option D. Okay, in number 3, it says a student plots a velocity time graph from the graph above. We want to know what will the total area of this velocity time graph be. Okay, so we know that up until this point we have positive velocity, okay, because the slope is always positive. Then we're going to have negative velocity once the slope starts pointing downwards. Since these are actually the same but opposite, we can imagine that our VT graph will look something like this. We'll have a positive area, then a negative area, but they look equal, so they'll actually add up to be equal to 0, and it looks like that is our option B. In number 4, it says a student plots an acceleration time graph from the displacement graph above. Okay, the acceleration time graph represents a change in, or the area of this graph represents a change in what? Okay, and actually for this we can just refer to our XVA chart. Okay, if we find area of acceleration time, it actually gets us change in velocity, and that was option B. Number 5, it says an object starts at rest and then reaches a speed v in time t. We want to know what the average velocity is. Okay, so we have to remember that the average is equal to delta x divided by delta t. So what we have to find is we have to find this delta x. To do that, we can use our first equation, x equals x naught plus v naught t plus 1/2 at squared. Okay, it starts from rest, so we know v naught is 0. And we can say delta x is x minus x naught, so I'm just bringing the x naught to the other side, is equal to 1/2 times a t squared. Okay, I'm going to put this in for my delta x, and I have v average is equal to 1/2 a t squared over delta t, which is just the same as t. Okay, I can cancel out this squared with this t on the bottom, and I have v average is 1/2 a t, which is option E. Okay. Number 6 is a little confusing because it has this weird kind of... Oh, sorry. No, that's number 7. Number 6 just says a body moving in the negative x direction passes the origin at time t equals 0. Between time t equals 0 and 3 seconds, the body has a constant speed of negative 15 meters per second. At t equals 3 seconds, the body is given a constant acceleration of 5 meters per second squared, and we want to know what's the final x direction. Okay, so this is a little bit confusing. Okay, we know that our thing between t equals 0 and t equals 3 has a certain motion, and between t equals 3 and forevermore has a second type of motion. Okay, so we can find the distance, or x, from 0 to 3, and then we can find x from 3 to 11 seconds. The total will be if we add these together. Okay, in the case from 0 to 3, we know that we have a constant speed of negative 15. Okay, so we know x from 0 to 3 is x naught. It says starts at the origin, so that's 0, plus negative 15t plus 1/2 at squared. It says it has a constant speed, so a goes away. And x from 0 to 3, we're going to plug in 3 for our time, is equal to negative 15 times 3, which is negative 45 meters. From 3 to 11, it gets a constant acceleration of plus 5 meters per second. So we have x from 3 to 11, and that is equal to x naught, or x at 3, plus v naught t plus 1/2 at squared. We're going to plug in negative 45 for x naught, okay, plus v naught, which is negative 15, t is 8 seconds, plus 1/2. Our acceleration is plus 5, 8 squared. Okay, so I'm going to zoom in on this. We have negative 45 minus 15 times 8 plus 1/2, 5 times 8 squared. Okay, you plug that into a calculator, and you end up with negative 5. So we have x equals negative 5, which is option B. Our last question says, which of the following graphs could represent the velocity time graph for an object whose motion map is shown above? Okay, so first of all, we haven't talked about motion maps, but that's okay because on the AP test, you might run into terminology or different types of ways of talking about things or representing things that are not talked about in class, because there are probably hundreds of ways of representing things. Okay, what a motion map is it tells you how far things get every second. Okay, so in the beginning you have a constant and pretty large velocity, so that might be represented here. And then we have a negative and smaller velocity, representing how far each thing gets each second. Okay, but since these are the same size, that means the velocity is constant while it's positive. These are the same size, so it's constant while it's negative. Okay, and option A is the only positive velocity and then negative velocity where the velocity stays constant.